So as we're getting our technical difficulties figured out, let's go through these here. I'm asking you how many days are between these dates. Now, if you recall, there's a page in your book. I believe it is page 396 in the new version of the textbook that has your calendar listed out from day 1 through 365. Now, obviously, these do not include leap years, so I made sure that none of the ones I have here include February 28th or 29th. But if we're going to look at those, if you look in your book, what day of the year is March 17th?
76.
76, good. What day of the year is November 2nd? What's that? 306, good. Now, since these two are in the same year, which is important, since they're in the same year, we can just subtract. 306 minus 76 is 230 days. So there's 230 days between those dates. Now for the next one, what day of the year is October 28th? 301. And February 14th? It's 45. Now these are not in the same year. These are in different years. Since they're in different years, the easiest way to think about it is with a timeline. Here's my October 28th. I have to go from that date to the end of the year. So I'm going to take 365, which is the full year, minus the 301, gives me 64 days. So there's 64 days there. And then from the beginning of the year to February 14th, well, that's just the 45 days. So then we're just going to add them together. 64 plus 45 gives me 109. So there's 109 days between those two dates. Next, I asked, what day is 120 days from April 23rd? Well, what day is April 23rd when we look it up? What's that?
113.
113. Perfect. So we're just going to add 120 to that, which is going to give us 233. So now if we read the table backwards, what day is day 233? August 21st. Very good. Any questions from that? Okay. I know we just got done doing the invoicing and all that dating in the last unit, but this table and coming up with these dates and a number of days is going to be important for us again in this unit. So what we're going to be talking about today, in the next 2 weeks actually, is simple interest. And in simple interest, all we're dealing with is we're dealing with a starting amount that's usually called the principal or the proceeds, depending on the type of loan it is. And to that, we're adding some sort of a fee or a charge for letting you borrow the money. In principle, that's called interest. If it's a proceeds, it's called a discount. To get some amount that is being paid back. For both of for the principal plus interest, that would be considered maturity value. For the proceeds plus discount, that would be also could be called a maturity value, but it's called the face value. Now it's a little bit confusing because when we look at the type up here, the type 1 where it's principal plus interest, the principal is sometimes referred to as the face value. But in all cases, we have some starting amount. We're adding some sort of a charge for letting you use that money to get an amount that is paid back. Now, there are two types of, these are called interest-bearing notes. Now, the word note implies that we are borrowing money, and for the most part, we are borrowing money or we're lending money to someone else, so we're talking about the borrowing side of the calculation. The only exception to that, which it's still borrowing or lending, is we're going to talk a little bit about treasury bills and bonds. Really, it is a loan. You're loaning money to the government and they're paying you interest. But we're going to talk about it as an investment as well. But anyway, between these interest-bearing notes, the first type is called simple interest note. And the second type is called a simple discount note. The difference is the face value. In a simple interest note, the face value is the amount you receive. So you're borrowing money, that's the amount you're actually going to get and you're going to get to keep and use. In a simple discount note, the face value is the amount you pay back. Now, that might not make a lot of sense because most people don't have a lot of experience with simple discount notes. But you might have like money, maybe you have an investment maturing and you know you're going to have a certain amount of money on this day. So they give you a loan based on you having that much money at that day. So they know you can pay back that amount. So then they work backwards to figure out how much they're going to give you.
Is that like a payday loan?
Very similar to that, yes. So then in a simple interest note, the fees or the charges, you're going to add interest to it. And that's going to give you that maturity value, which is the amount you pay back. In a simple discount note, we're going to subtract from the amount you're going to pay back, we're going to subtract something called the discount, which is just the interest. But because we're deducting it, it's called a discount. And once you subtract the discount, that gives you the amount you receive, which is called the proceeds.
So if I wanted like $500 and they already took out the $200 to begin with, and I'd only get $300?
Exactly.
Front end as opposed to
Exactly. Yeah, if it's a loan that's going to cost you $200 in interest, if you're taking out a $1,000 loan, you're only going to get $800. Then you pay back, because it's a $1,000 loan, you pay back the $1,000 at the end. The face value of the loan is what you pay back on that discount note. On the simple interest note, the face value is what you receive. So you take out a $1,000 loan, you get $1,000, and at the end you pay back that much plus the interest. So if it's $200 with interest, you pay back $1,200. Now for most of tonight, we are going to focus on this side of the table here, the simple interest-bearing notes. Next week's when we're going to spend most of our time talking about the discount notes, simple discount notes. So we're going to look at the simple interest formula. And this simple interest formula applies to both types of notes, but it's worded a little bit differently for the discount note. Here we're going to look at the simple interest note is I equals P times R times T. Usually we just say I equals PRT for short. I is the dollar amount of the interest. P is the principal, which is that starting amount that you begin with. R is the rate, and that's just a percent as a decimal. And T is time. However, time is always expressed in years. So this gives you the dollar amount of the interest. So let's say that we are going to borrow $2,400 at 9% for 2 years. We're going to find the interest. So the amount of interest, principal times rate times time. We are finding the amount of interest here. What's P? Principal is $2,400. What is R? 9%, but we're going to write it as a decimal, so 0.09. And T, time, 2 years. Nope, remember time is always in years, so it's just 2 years. So we're just going to multiply that out. 2,400 times 0.09 times 2 gives us interest of $432. So that is the interest charged on that loan. Now, it's not terribly practical to use simple interest over a 2-year period. Almost nobody does simple interest for that long of a period of time. They'll almost always, at some point in that period of time, charge you intermediate interest. But the only thing that really does do that type of interest is savings bonds and stuff like that. So most simple interest is usually less than a year. In fact, usually less than 6 months to really use simple interest. Well, the next stage of this is to talk about something called maturity value. We're not by any means done doing examples of simple interest, but we got to put this next formula in here to tie it all together a bit. Maturity value is the amount due at the end. That's the amount paid back at the end. At maturity. Maturity value, MV, is equal to your principal plus your interest. That one shouldn't be a big surprise, right? So for the example we just did up here, borrowing $2,400 at 9% for 2 years, our maturity value is going to be that $2,400 plus the interest of $432, which will be $2,832. Any questions so far? So now, as I mentioned, it's not very often that they'll let you go for 2 years on simple interest. So let's take a look at something a little more reasonable. Let's say you borrow $900 at 12% for 4 months. Find the interest and maturity value. I might also word that as find the interest and the amount paid back, which is the same as asking for the maturity value. So again, we're going to start out with that interest formula, I equals PRT. Do we know I? No, that's what we're looking for. Do we know P? That's the $900. Now, I'm in the habit of putting the rate in parentheses just to separate it, but you could just use the time symbol if you wanted to. What's R? 0.12. There we go. T, however, was 4 months, but we said the time is always expressed in years. Well, how do we express 4 months in terms of years? There are 12 months in a year. It's 4/12. You could, but you don't need to because we're just going to punch it in the calculator anyway. We're not going to do these interest calculations by hand at this point. But oddly enough, in a few minutes, we're going to discuss some adjustments we make to the formula to make it easier to calculate by hand, even though we don't do it that way anymore. Yep. So, when you punch this in the calculator, you could use the fraction key for the 4/12, but sometimes it'll give you your answer as a fraction. And since we're dealing with money, we want it as a decimal. So the easiest way to enter it is just 900 times 0.12 times 4 divided by 12. And it'll give us exactly $36 in interest this time. So then to find the maturity value, what are we going to do? The $900 principal plus the $36 in interest. Good. So that's $936 is what's paid back. That's the maturity value. Why don't you guys try one? Let's say you are going to borrow $1,500 at 9% for, let's do 8 months. Again, find the interest and the amount paid back. I'll let you do that, and I'll give you a minute to do that in your notes. So I'm not going to write out the formula here. I'm just going to plug the numbers in. So our interest is equal to, what's our principal? $1,500. What's our rate? 0.09. Good. And our time? 8/12. And what's that come out to be? 90 bucks? So $90 is our interest. So that means our maturity value, the amount paid back, is going to be $1,500 plus 90, $1,590. How many of you had that? Cool. Anybody not sure how I got it? Perfect. Well, we all know that we got to throw some algebra into this. Let's say we have a $32,000 car loan. Accumulates, what do I want to put on it? $160 in interest for a month. Find the rate being charged. So here we still have our formula. I equals PRT. But in this case, we know the interest. What goes in for I? 160. Do we know the principal? 32,000. Do we know the rate? We're being asked to find the rate. So R we do not know. Do we know the time? A month, 1 month, so 1/12. Now here's where we're going to have to use our calculator to its abilities a little bit here. Because before we solve this, we have to combine the 32,000 and the 1/12. And that's going to give us a repeating decimal. So to avoid some pretty serious round-off errors, we're going to have to keep it in our calculator. So the 160 here doesn't change yet. But we have to do 32,000 times 1/12. So we're going to do 32,000 times 1. Oops, I missed a 0 there. 32,000 times 1 divided by 12 gives us 2,666.666666. I'm going to write it down for right now as 2,666.67. That's still times R, because we're looking for R. But notice I did not clear my calculator, and I'm not going to clear my calculator. To solve this now, we have to divide by that 2666.67. So here's what we're going to do. That's going to leave R by itself over there. But here's what we're going to do. You're going to type in, you're not going to clear it at all. You're just going to leave that there. You're going to type in 160 divided by, and remember that answer key that I showed you a few weeks back? You hit second, and then it's down by your equals key. There should be above the negative. It should say ANS. You hit that. That's telling the calculator you're going to divide that 160 by the previous answer. So you don't have to type it back in. So that gives you 0.06. Which, of course, 0.06 is what percent? 6% is the interest rate. Now, just to show you how the round-off errors can sneak up on us, if we had done 160 divided by 2,666.67, it would have been 0.0599999, which we would have most likely still rounded off to 6%, but there are times where it can throw you off.
The textbook says never round until the end, unless
Yep.
you're looking estimate.
Yep.
What does your answer key look like? I don't know that my calculator has it.
What type of calculator do you have?
Text instruments 30XA.
30XA, okay, yep. Is it a one-line display or a two-line display?
One.
A one-line, okay. So what you have to do on yours,
Yeah.
when you've got that, you take the 32,000 times 1/12, and you get that 2666.666666, blah, blah, blah. On your calculator, what you're going to do is there's a key right above the number pad that looks like this, 1/x.
Okay. Yeah.
You're going to press that key, then you're going to do times 160. Should give you the 0.06.
I don't know what my calculator looks like.
I've seen a few of them before. That might be a sign that I need to get out of the house more. Or out of the school, one of the two. Now again, if you can't remember that process, All I will say is when you write this number down on your calculator screen, just write down as many digits as you can, and when you re-enter it, re-enter as many digits as you can. So that if you get, realistically, if you get at least 5 or 6 decimal places in here, the round off error won't be significant. You know, we did this, I rounded off to 2 decimal places, but if I did 160 divided by 2666 point, put a bunch of decimal places in there, it comes out, it rounds itself off to 0.06. Okay, well, let's do another example. Let's say that for the month, you are charged $96 interest on an 8% loan. How much is owed? So it's still interest equals principal times rate times time. Do we know I? Yes, we do. 96 bucks. Do we know P? No. The principal is what we're looking for. They didn't say principal or starting amount, but the amount owed has to be that principal. So we are looking for P. We better know R because we're already missing the P. What's R? 0.08 for 8%. And T, once again, 1/12. So now here's another example where we need to combine these two numbers. So 0.08 times 1/12 is going to give us 0.0066666666666667. So 96 equals 0.0066666667 times P. So now we're going to go through that same process to solve for P. We have to divide by this. So again, on my calculator, I'm just going to type in 96 divided by second answer. It gives me $14,400. So the principal was $14,400. Any questions? So let's say we have a 7% simple interest loan for $6,000. Accumulates $1,050 in interest. Find the term of the loan. Finding the term is just saying find the amount of time that the loan was over, the time of the loan. So I equals PRT. Do we know I? Yes, what is it? Careful. I is the dollar amount, yes, 1,050. Do we know P? 6,000. Very good. Do we know R? 0.07. And we are looking for T then. So here, we're going to combine the 6,000 times 0.07, which is what, 420? And so then we solve for T by doing what? Dividing by 420. So 1,050 divided by 420 is, I believe, 2.5. Yes, it is. 2.5 equals T. What's 2.5 stand for? 2.5 years. Remember, time is always in years. Now this next one, I want to be a little bit sneaky, and I want you guys to try it in your notes, see if you can figure it out. How long does it take for a 6% investment to grow from $8,000 to $12,000? Of course, assuming simple interest. I'm going to give you guys a couple minutes to try that in your notes, see what you come up with. Let's take a look here. I'm going to leave the I empty for a second here. What's the principal? 8,000 is the starting amount. What's the rate? 0.06 for the 6%. We are looking for the time. It said how long. What is the interest? 4,000. Very good. We subtracted the 8,000 from the 12,000 to get that it had to grow $4,000. That has to be the amount of the interest. Any questions so far? Okay, so now we have to combine. The 4,000 here isn't going to change, but we're going to take the 8,000 times 0.06, which is going to be, I believe, 480. And then our next step, divide by the 480. We have 8.33 equals T. So that is 8 1/3 years. If you did 8.33 years, that'd be fine. Or you could say 8 years and 4 months. So any of those three answers, 8.33 or 8 1/3 or 8 years, 4 months. Do please make sure you put the years on there when you label it, though. My math lab may specify it wants it in a certain format. Usually they want you to leave it in a decimal number of years rounded to a certain decimal place. So the nearest 10th of a year or 100th of a year. So I'm going to have you try this one. Find the rate required to accumulate $120 in interest on an $8,000 loan in 3 months. Give that one a shot. Okay, so we know I is 120. P, 8,000. R, that's what we're finding. T, 3 over 12. Perfect. So now we're going to combine the 8,000 with the 3/12, which gives us 2,000. Then what? Divide by 2,000. Which gives us 0.06, so 6%. Any questions there? Good. Now let's talk about days instead of months. So far, we've just assumed a month is a month. And if they list the time in months, that's how I want you to do it. If they say 3 months, it's 3/12. Don't worry about which months it are. Don't worry about whether it's a 30-day month, 31-day month, or if it's that messed up thing we call February. Let's say that you borrow, and this used to happen to me a lot when I was running my business more aggressively. You need short-term business loans. So you might borrow $3,000 at them, usually give you a little bit higher rates, let's say at 11% for 90 days. To figure out the interest and the maturity value, I mean the interest is really the big step. You find the dollar amount of the interest. Our principal is 3,000. Our rate 0.11. And here's the tricky part. What should we put in for the time? You would think 90 over 365 would make sense, wouldn't you? But for the most part, we don't. There are actually 2 types of interest that can be calculated on the days. When you're using days for your time, there's something called ordinary interest. Ordinary interest is what is ordinarily used, and it is the most common one used. If it does not specify what type of interest, you will assume ordinary interest. For ordinary interest, they use the days divided by 360. Then there's also something called exact interest. For exact interest, they use the days divided by 365. Now, the original purpose of ordinary interest, I mean, the exact interest, days divided by 365, that seems pretty logical because there's 365 days in a year. The original purpose of ordinary interest was to help with bookkeeping. I mean, interest has been around for hundreds of years. And you date back to the late 1700s when the first banks in the United States originated. People would invest money and they would pay interest on that money. Well, they didn't have calculators. They didn't even have mechanical adding machines up until the late 1800s, early 1900s. So to do the interest, they actually had to sit down and calculate it out by hand. To make it simpler on themselves, they just figured every year was 360 days. Every month was 30 days because those numbers work out nice and roundly. So when they calculated out the interest, they didn't have any really ugly, I mean, they still had some sort of ugly decimals, but not any really ugly decimals to deal with. So that's where the origin of that 360 days being used came from. Well, now that we have all sorts of fancy electronic calculating devices, we still use it for two reasons. One is it's just customary. Two is, and this one way more important than a lot of people give it credit for. If you're taking the days divided by 360 instead of 365, what does that do to the amount of interest? Slightly more interest. The bank is charging you that interest. So if they're charging you that interest, if they can squeeze a couple extra pennies out of you, they're going to do it. So we're going to do this problem here both ways. Now, since it wasn't specified what type of interest, what type should we have assumed? Ordinary. So that would be out of 360 instead of 365. So that's the way we're going to do it first. So let's figure out the amount of interest there. 3,000 times 0.11 times 90 divided by 360. Oops. Let's try that again. It helps when we use 0.11 instead of 0.00. There we go. $82.50 is the amount of interest. That was ordinary interest. And that was using the 360. Let's recalculate this again using exact. So it'd be 90 over 365. So it'd be 3,000 times 0.11 times 90 divided by 365. $81.37. So that's exact. So you can see here, just on 90 days on only a $3,000 loan, it makes a difference of $1.13. $36.9, yeah, so 37.
I don't know why Mike came out 81 and 27 apart.
Try her again. If it doesn't work, let me know and I'll come take a look at it. I have pushed past our break here, so let's go ahead and take our break at 6:22. Let's come back at 6:32.